Hello, good morning students. Now today we are discussing about the secondary chemistry. In this the name of the chapter is D and A block elements. In this very important question is write the characteristic properties of transition elements. In this the very important question. Transition elements exhibit the characteristic properties due to these four reasons. The following the four reasons. The one of the reason is small atomic size, high nuclear charge, high ionization potential, and the fourth reason is presence of unpaired electrons in d orbital. Due to these four reasons, the transition elements which shows the characteristic properties are: number one, they exhibit the variable oxidation number, means the one element can exhibit the more than one oxidation number. It is called variable oxidation number. For example, the manganese can exhibit the +2 oxidation number, and +7 oxidation number, and +2 oxidation number, +4 oxidation numbers, like this. And the second transition element property is they have para and ferromagnetic properties with one or more unpaired electrons in d orbitals. So in these elements, due to presence of more than one unpaired electrons, it can exhibit the paramagnetic property, and they can exhibit also ferromagnetic nature also. And the third transition property is they form colors. So due to presence of unpaired electrons, these transition elements can exhibit the color property also. For example, iron +2 exhibit the green color, and copper +2 is exhibit the blue color due to absorption of energy from the visible region. Next, the fourth point is they can form complex compounds. Complex compounds, they can form the coordination numbers, nothing but, for example, hexaamino cobalt chloride. It is an complex compound of transition elements. Next point is they can exhibit the catalytic property. What is meant by catalytic property? Because of the element can increase the rate of reaction in this preparation of complex compounds. For example, iron, molybdenum used as a catalyst in the preparation of ammonia by Haber's process. Next property is they have alloy forming ability. For example, these elements can also alloys due to they can combine with metals or non-metals or metalloids to form the homogeneous mixture is called alloy. For example, transition elements of the alloys are brass and bronze and German silver, gunmetal, benmetal. These are the alloys of transition elements. And the seventh one, they form interstitial compounds also. Right, the very important question is Werner theory in D and A block elements. The question is Werner theory of coordination compounds. It was proposed by Alfred Werner to explain the mechanism and formation of complex compounds. In this theory, the first very important postulate is every complex compound has a central atom or ion. The second point, the central atom or ion, it shows two types of valencies. The first one is primary valency and the secondary one is secondary valency. Discussing about the primary valency. In this, the very important points are the primary valency. It indicates the oxidation state of metal ion. And the second point, it is satisfied by only negative ligands. Third point, it is represented by dotted lines. And the fourth point, it is ionizable in water. Fifth point, ligands are held with central metal by ionic bonds. And the sixth point, these are non-directional bonds. And the seventh point, it does not determine the shape of the complex compound. About secondary valency, in this the first point is it indicates the coordination number of metal ion. Second point, it is satisfied by negative ligands or neutral molecules. Third point, it is represented by continuous line or dash. Fourth point, it is non-ionizable in water. Fifth point, ligands are held with central metal by dative bonds. Sixth point, it can determine the shape of the complex compound. And the seventh point, these are directional bonds. And the eighth very important point, sometimes the negative ligands must be satisfied with both primary valency and secondary valency. It indicates with both discontinuous line and continuous line. Example, the best example is penta-amino cobalt chloride. In this cobalt penta-amino cobalt chloride, the oxidation number of cobalt is +3 and the coordination number is 6. In this, the example structure of this penta-amino cobalt chloride, the central position it contains cobalt +3 ion and the 6 ammonias are acting as a secondary ligands and 3 chlorine act as a primary valency. In these 3 chlorines, one chlorine is act as a primary valency as well as in secondary valency.